Hello and welcome to the Module 4 fourth video, Actuators. In this lesson, we will talk about how to interact with our environment using our Raspberry Pi. We can use a broad range of actuators with our Raspberry Pi, for example, DC motors, servo motors, relays, LEDs, displays, etc. In this lesson, we are going to show how to use an OLED screen and how to interface with a DC motor. We are going to use a small OLED monochrome screen that connects through SPI bus. We can easily buy this kind of displays on the internet. To connect our display to the Raspberry, we use the connection shown on the figure. Red wire is 3.3 volts and black is ground. The other ones are data connected to the MOSI pin and clock connected to the SPI clock. Chip select and reset are connected to the general purpose pins. To use the SPI port, we must enable the Raspberry Pi configuration. We must enable in the Raspberry Pi configuration program in the same way we have previously done for the camera and the I2C bus. We are going to use a driver from Adafruit to interact with our display. We download it from GitHub using git clone. If we haven't installed Git previously, we can install it with the apt-get command. Then we build and install the driver using the setup Python script. To use the driver, we have to configure several parameters. For example, the SPI, DC and reset pins, the size of the display, and other parameters like speed, and etc. Then we initialize the library. We use the Python image library to create a binary image with the same resolution of our OLED screen. We grade the image using this library. Finally, we grade the image on the display memory and refresh the display. Now we are going to learn how to use a DC motor with our Raspberry Pi. DC motors cannot be connected directly to our Raspberry Pi as they draw too much current. We need to use a motor driver. DC motor drivers are usually H-bridges. H-bridges are electronic circuits that can control large power delivered to a load. They have the interesting property of allowing to reverse the direction of the current that goes through the load. In this case of the DC motor, this means that we can invert the rotation direction. In this example, we are going to use the LM298 integrated circuit that contains two H-bridges on the same circuit. We can buy breakout boards for these chips on internet that expose the main interface. In the figure, we show the most common interface for H-bridge breakouts. Note that we need a separate power source for our motor as it can draw too much current and destroy our Raspberry Pi's power supply. To use the motor, we are going to use the GBO0 library as previously done for the LEDs and other things. First, we need to import the motor class. Then we configure the H-bridge input pins, which in this example are pins 4 and 14. Next, we enter it into an endless loop where we move the motor forward and backward every 5 seconds. To control the speed of the motor, we are going to use a technique called pulse width modulation, or PWM. This technique is based on the low-pass filter nature of our load. It consists on create a fast series of pulses with a varying duty cycle. Our load acts as a low-pass filter and averages the signal. The greater duty cycle, the greater the power delivered to the load. To create a PWM out in our Raspberry, We use the PWM output device from the GPO0 library. We configured the library to output a pulse on port 17 with a frequency of 1 kHz. To vary the duty cycle, we use the value member, which ranges between 0 and 1. LM298 has a pin called Enable, which is very convenient to connect to our pulse. Through this pulse, we connect and disconnect the whole bridge, regardless of which input signal is active. In this example, we must connect the Enable pin to the pin 17. The result of the program is shown in this video, where we can see how the motor reverses its speed every 5 seconds. In this lesson, we have seen how to control motors using PWM and how to use SPI port to control an OLED display. In the next module, we will learn how to mix all these concepts and make an integrated application. Thank you and goodbye.